7.5 is to solve special types of systems. Up to this point, we've just had systems. They all have an X and a Y for an answer. But we know from that worksheet we did right after the Chapter 7 or the Chapter 6 test. Remember the worksheet with the 8 graphs on it, and one of them had parallel lines? Number 7 had parallel lines on that worksheet? When you did some graphing for me before we started graphing to solve linear systems? Remember there were parallel lines? Yes? No? Okay. We're going to talk about parallel lines today, and also we're going to talk about when two lines really are one on top of each other, the same line. So we're going to start out here with linear systems that have no solution. These kind of systems will be parallel lines in the end. Parallel lines. So that's why I want you to have that sheet of graph paper out so that we can do some graphing of these. You're going to solve this one two ways. We're going to graph it, and we're going to do the elimination method. Okay, I'm going to show you how it works graphically and algebraically. We're going to do graphically first. I want you to take a moment and write these two equations in y equals mx plus b form right now, please. The second? Okay, Ellie, tell me on the first one, what do we got for y equals?
Y equals negative 2 plus 2/3 x.
Negative 2 plus 2/3 x. And so let's check out here. That would be negative 3y equals 6 minus 2x. You divided everybody by negative 3. I agree with that. That's one equation that we're going to work with. Okay? Ben, what's your equation?
Y equals 4 over 3 plus 2/3 x.
4 over 3 plus 2/3 x. And let's see, we're starting out with negative 3y equals negative 4 minus 2x. Divide everybody by negative 3. I agree with Ben's equation here also. All right, if you didn't get these two y equals equations, make sure you have them jotted down correctly. I'll give a moment to do that. Okay, our two lines that are up here, and this negative 4/3 that is up here, that is not a negative 4/3, excuse me, positive 4/3. That is 1 and a third, and then you go up 1, 2, 1, 2, 3 to the right. And you have to stay on that same area of the line. So Nick has that drawn, and Jordan had the other one drawn. What do you notice about the two lines? They're parallel. Will they ever cross if they're parallel? No, no, never, never, huh? They will never cross. So what we're going to write up here is no solution. That is your answer. When you are graphing and you come up with parallel lines, you can stop and write no solution as the answer because they will never intersect. There is no answer to the system because they'll never intersect. Now we're going to look at this system through elimination. So I'm going to write this down here again. So we have our system down here, 2x minus 3y equals 6 and 2x minus 3y equals negative 4. In order to be able to add the two equations together, one of the two variables has to drop out. So what should we multiply by so that we have opposites either on our x or our y? Any thoughts there, Ben?
Negative 1.
Negative 1, multiply which equation by negative 1?
The first one.
So negative and negative. Negative, positive, and negative. Okay? When we do that, we add our x's together. What happens to our x's? What happens? They cancel. What happens to our y's? They cancel too. So when both things cancel, what am I left with on the left-hand side? 0. I get 0 equals, what's the right-hand side equal to? Negative 10. Okay, ladies, gentlemen, remember when we solved equations back in chapter 3? And even, I'll just go back to chapter 3. When our variables dropped out, we looked to see whether that was a true or a false statement. Is it true or false? False. So you should be thinking false. That's what you're thinking. And what you're going to write for an answer if it's a false statement is no solution. That's right. No solution. So if you're working out the problem, one of the algebraic ways, and all of your variables drop out, you need to look to see if that is a true or a false statement. A false statement gives you no solution. Okay? That should be a hint to you, oh, those are parallel lines. If I were to graph that, they'd be parallel to each other. This is one of the special kinds of problems you're going to come upon, where the variables are going to drop out and you get a false statement left. That false statement tells you no solution. Okay? Any troubles there? Okay? That's similar to that number 7 on that joke sheet I had given you after the chapter 6 test, where I kind of gave you a taste of doing some of the graphing of the linear systems. The next one that we're going to look at is a linear system with infinitely many solutions. Ooh, this is the other kind. Infinitely many. I have two equations up here, 4x minus 2y equal 8, and y equal 2x minus 4. I would like you to, could I have a volunteer to graph that second equation that's already in y equals mx plus b form? Somebody who hasn't been up to the board yet. Angela, come on up to the board. Okay, Angela has the second equation graphed up there, y equals 2x minus 4. And while she was graphing that, I asked you to solve this top equation for y. Anybody have that one solved for y for me and can tell me what it looks like? Carissa?
Y equals negative 4 plus 2x.
Oh, that looks kind of familiar. What do you guys notice? Jordan? These two equations right here are the same equations. This one became y equals negative 4 plus 2x. Could Carissa have said 2x minus 4 to me? Absolutely. If I were to graph that over here, where is it going to be? Jordan?
It's going to be the same.
It's going to be the same spot as what the one that Angela just graphed for me. This is what's going to happen graphically when your two equations really are the same line. How many times do they intersect if they're the same line? Do they intersect once? Twice? 3 times, a lady? 3 times? 4 times? 5 times? How many times, Ben?
They don't intersect at all.
Well, if I graph this other line that Carissa just gave me on top of this line, and I'm going to get the exact same points. Smacking it every time, all of the time. How many times is it intersecting? Infinite. Exactly. So many times we can't count because every point on that line is touching it, right? It's not like doing, a bunny hop and, every once in a while touching it, is it? No. All the time it's touching it. So we say there is an infinite number of solutions. We don't say all real numbers because it's not all of the numbers up there. There's an infinite number of solutions. I can't give you them all. I know that it intersects here and it intersects here and it intersects here and here. It also intersects here and it intersects here and here and here. There are a whole bunch of spots on the line that it intersects. And the line goes on forever in both directions, so it's an infinite number of XY pairs. But I can't tell you what they all are. Now, if we do this via elimination, you know what? Let's change this. Let's not say elimination. Let's do a little practice for our quiz. Let's do substitution down here. Okay, let's do substitution. We have the 4x minus 2y equals 8, and y equals 2x minus 4. We want to substitute. What should we substitute in where? Any thoughts? What should we substitute in where? What do you say, Jordan?
To 2x minus 4 into this equation, so it'd be 4 times 2x.
Okay, so we're going to put it into the 4x minus 2y equals 8 equation. All right, so we have 4x minus 2. Here is where I need parentheses. 2x minus 4 equals my 8, because I've got that 2 times whatever y is. It's actually a negative 2 times whatever y is. Okay, I need a little distributive help. Mr. Peacock, 4x what?
Negative 4
Negative.
x, and then 8. Positive 8.
Positive 8? Okay, thank you. All right, ladies, gentlemen, 4x minus 4x, what does it give you? 0. So that leaves me with 8 equal to 8. True or false? True or false? True. When you get a true statement with these systems, you are then going to have an infinite number of solutions. Okay, you're thinking here that this is true, and that's going to give you an infinite number of solutions. All your variables drop out, and it was a true statement. Remember the parallel? What kind of statement was on the parallel? What kind of statement was on the parallel? False. Okay? With the infinite number of solutions, it's going to be a true. Angela.
Would we have to do both of those, or can we just like choose one?
You have to know what's happening depending on what you're working on. If you're graphing and this happens, you have to know it's an infinite number. If you're doing a substitution problem and it happens that all the variables drop out, you have to know I'm looking at a true or a false statement. So I'm not saying that you can choose which one to do, because on my test, I'm going to tell you most of the time, I need you to graph here. I need you to do linear systems or linear combination here, substitution here. But if I give you a choice, then you'll probably either choose one of the two algebraic methods. I don't know too many people who choose to do the graphing method. Okay. So you need to know both. Anybody else? Jake?
Do like a multiplying for like the elimination.
The quiz today, we're not multiplying. You're doing substitution and graphing. Okay. The quiz on Thursday, you're doing the multiplying. Okay, the elimination method. All right. Number of solutions. We need to talk about number of solutions. When there is one solution, no solution, and infinitely many, we're going to discuss about the slopes. We were just commenting on no solution type problems. What kind of lines are no solutions? What kind of lines have no solution? Jordan?
Parallel.
These are parallel lines. So we're going to say, hey, parallel lines. What do you know about the slopes of parallel lines? What do you know about the slopes of parallel lines? Anybody know about the slopes of parallel lines? Rebecca?
Are they the same?
They are. You're going to have the same slope. If the equation is y equals mx plus b, you're going to have the same slope. Infinitely many solutions. What kind of lines are infinitely many solutions? Not parallel lines. Jordan?
They're the same line.
Yes, they are the same line. So what do we know about the slope of two equations that have the same line? What do we know about the slope of two equations that are really the same line? I'm a little worried here. Jordan, I'm going to let you answer. It's the same. It's the same slope. But what else is also the same? It's the same slope and the same y-intercept. That's right. How about parallel lines? Do they have the same y-intercept? No. So I'm going to put up here different y-intercept on the parallel lines. This is in the good old y equals mx plus b format. You can look at an equation and go, I already know whether it's no solution or infinitely many if it's in y equals mx plus b. Because parallel lines are going to have the same slope but a different y-intercept. And infinitely many solutions is going to have the same slope and the same y-intercept. They're going to end up being the same line. How do you know that it's one solution then? When you look at the two equations and you're looking at their slope, hint, hint, how do you know that there is one solution? Okay, Jordan, I'll let you answer there.
If their slope's different.
They have different slope. That's right, because they're going to intersect. When their slopes are different, they will always intersect. Now, why am I putting this up here? Because one of the things on my test that you will have to be able to do is put an equation into y equals mx plus b and tell me, is there one solution, no solution, or infinitely many, and not graph it and not do substitution or linear combination. You don't get to do any of those ways. You just get to look at the equations. It's called without solving the system. You're just looking at the two equations. So if I have 3x plus 5y equals 6 and 6x minus 10y equal a negative 12. Put these two into y equals mx plus b. Work with your partner to put them in y equals mx plus b. All right, looking at these two equations, they're worked out so that we can see what each of them has for an answer there. And when Ellie worked this out, she put decimals in, which is not wrong. It's just when we graph, we normally would be graphing with our slope being a fraction. So be careful about that. These two, are they the same equations? Absolutely. Therefore, when I'm looking at this, I've got a slope of 3/5 on each one. And what do I notice about the y-intercept? They're the same. So therefore, how many solutions? Infinitely many. So we'd write down infinitely, and infinitely will be spelled out, ladies and gentlemen. Infinitely many solutions. I-N-F-I-N-I-T-E-L-Y. Infinitely many solutions. Do not give me infinity solutions. Okay, it's not infinity, it's infinitely. Okay? Let's see here. Two groups of people are buying pizzas. The number of pizzas and the total cost are below. How much does a large cost and how much does a medium cost? Take a look at this information here. We've got 4 mediums and 12 larges, cost $168. And we have 8 mediums and 24 larges, cost $336. Could you come up with 2 equations with your partner right now for this system? Okay, come up with 2 equations for this. The 2 equations that Kyle wrote up here, 4x plus 12y equal $168 and 8x plus 24y equals $336, are correct for the problem. He had to give one of them x and one of them y. He chose medium bx and large y. That's fine. Awesome. Equals the total amount of money that's there. We have to find out what the price of a medium is and what the price of a small is. What would be a good way to solve this problem? Any thoughts? What would be a good way to solve this, Shelby?
Put in y equals mx plus b.
I could, but I don't want to graph that thing. You can't make me, you can't make me, you can't make me. You want to put it in y equals mx plus b? Or did you not graph it?
I didn't graph it.
Oh, you didn't graph it. Okay, what'd you do with the y equals mx plus b then?
I solved for y.
solve for y, and thus you came up with what?
I got y equals 14 minus 1/3 x.
14 minus 1/3 x. Did you have another equation?
I got the same one.
Ooh, you got the same for both. What does that tell you about this problem?
There is infinite solutions.
There's infinitely many solutions. Yes, that does tell you there are infinitely many solutions. Okay, when Shelby did that, she put them both in y equals mx plus b. Now, normally when you're solving a story problem, that isn't probably what you would have done, is put them both in y equals mx plus b. What's another way to start solving this problem, Jordan?
I was going to combine them, so I
Linear combination, okay?
yeah. So I chose the first one times negative.
Times a negative, what? 2?
Yeah.
Oh, okay, that makes things even better here. So that we'll have, let me take away what I just did. Undo. All right. So you're taking times a negative 2. And what does that give you, Jordan?
Negative 8x, negative 24y equals negative 3.
When we add these two equations together, what do we get, ladies and gentlemen? 0 equals 0. True or false? True. So again, we come right back to Shelby's idea of infinitely many solutions. All right. Normally, you start solving your problem, you find out that your variables dropped out. That's normally how we solve our story problems. But Shelby was using a different tactic there, which is not wrong. Okay. Questions? 7.5 is done.